Okay, measuring instruments. Measuring instrument is a device or instrument that can be used to determine the value or magnitude of an unknown quantity. You must know a moving coil meter, you must know the construction. Well, if you look at this, the drawing that's in the textbook also consists of a permanent magnet, which is this purple, a pivoting coil of wire, which is there, the orange, and then a pointer attached to the coil. And there's the pointer attached to the coil, and then the control spring, the green. You must be able to draw that also and label it. Then you need to know the operation. Current passes through the coil. It experiences a force which rotates the coil. The needle is said to be deflected. Basically, the current passes through here. That's a coil. When current passes through a coil, it will set up a magnetic field. There, that horseshoe magnet is a permanent magnet. So you have one magnetic field and another magnetic field. They will have opposite polarities, and that will cause a force, and it will move the pointer. The greater the force or the bigger the current that flows through this coil, obviously it will set up a bigger magnetic field, the greater this pointer will experience a greater force. Understand? So if you pass one current through there, it will be a small value, small magnetic field, it will only move to 1. If you pass 10 current through it, it will set up a bigger magnetic field and it will move to 10. So current passes through the coil, experience a force which rotates the coil. The needle is said to be deflected. So this rotation is opposed by a control spring, which is the green one there. The bigger the current, greater the deflection. Maximum current called full scale deflection, or IFSD. Then you need to know damping. Obviously, this pointer it's a analog meter. Pointer will vibrate or oscillate, which can make it difficult to read. You need to get rid of it. Now, damping is a process of smoothing out the oscillation of the pointer. So we don't want to have that shivering nonsense. You need to get rid of it. Get rid of it by making use of damping. And damping can get two types: eddy current and air friction. You just need to know them. Now, if you want to look further, eddy current method where the induced current is opposed to the current created by the magnetic field, because there's two currents. That's the permanent magnet and the coil currents, opposed polarity. That's where you get this eddy currents, the induced current. Then air friction, making use of an air-type chamber containing a windmill vane attached to the coil. So you need to know eddy current and air friction. Then you need to know the ammeter. We connect an ammeter in series. There's a symbol. Ammeter has a low resistance. Why? Because you don't want it to affect the voltage of the circuit. How do you increase the range of an ammeter? We increase by adding a parallel resistor. Please, this is for an analog meter. So you add a parallel resistor. So there is a resistor in parallel. That represents the meter, and that is the resistor that you add. When you add it in parallel, there is the formula. Call that the shunt resistor. Current to the meter, IM, that's the full scale current. That is the resistance of the meter, and that is the current to the meter. You must know that the current through the shunt is equal to the I total minus IM. So if you have IFSD, which is the total, minus the current through there, which is this, is equal minus this one will be equal to this one. I shunt times R shunt is equal to IM times Rm. This is also equal to I times R is equal to voltage. Voltage of the shunt is equal to voltage of the meter. Because if you have to have the voltage across here, it will be equal to the voltage across there because it's in parallel. If you look at the example in your textbook, there's one in your textbook. There's an ammeter with a resistance of 20 ohm and a full scale deflection current of 1 milliamp used to measure current up to 5 milliamps. Calculate the value of the shunt resistance. So you have to calculate R shunt, and R shunt is equal IM RM I minus IM. So there's it. There they tell you a ammeter with a resistor, meter resistance of 20 ohm, so RM is 20 ohm. They say full scale deflection current is 1 milliamp. The deflection current is experienced in the meter, so that will be IM will be 1 milliamp, IM 1 milliamp, and then is to be used to measure a current of 5 milliamps, so that will be 5 milliamps. So I work it out, 5 ohm, straight forward. Okay, then after this you need to know the voltmeter. So voltmeter, we know we connect a voltmeter in parallel. You increase the range of a voltmeter by adding this time adding a series resistor. Meter resistor is in series, and to calculate that series resistor is voltage over Im minus Rm. Also know that the current passing through this meter is equal to the current passing through the resistor because it's in series. This is the example in your textbook. Meter full scale deflection of 1 milliamps and a resistance of 150 ohm. Calculate the value of the series resistor so that the instrument can measure voltage of 10 volt. Series resistor, there is a formula RS V over IM. This is the resistor, series resistor, and that's the voltage. And the voltage is 10 volt. That is current through meter, and they say the current through meter is the deflection one is always the meter, the pointer which is being deflected. So IM 1 milliamp, RM resistance of the meter 150. Plain simple calculation. Then for all of these meters you must know of a multi-range voltmeter. Multi-range is separate series. You add a separate series resistor for each one, meaning for each range it's a make before break switch, and that's also included in the circuit. It's to protect the meter, and the calculation is the same as for a single resistor that you add, so you use the same formula. If you look at the drawing there's it. So here's a make before break switch, can also be a relay. Each one of these, if you have to work it out for this range or this range or this range, you work it for this range, you work it out like you work it out for a simple separate one, this separate one, this one separate one. Okay, then you must also just know that when you are doing the ammeter, there's also for the ammeter also have a multi-range, and ammeter, remember ammeter, this is how it looks for the ammeter. Remember you add a shunt resistor, and the shunt resistor, there is a shunt resistor for each range, 1 amp, 5 amp, 10 amp range. Also separate shunt resistor for each range. Switch, a make break switch to protect the meter, and calculation is same as a single shunt. So for the voltmeter and the ammeter, when it comes to multi-range ammeter or multi-range voltmeter, you just have to add multiple resistors. The ammeter, multiple resistors in parallel, and you work it out the calculation separately the same. Obviously you're going to add it all together separately. For the voltmeter the same, add each one get their own resistor, and your calculation is exactly the same. Ohmmeter, next one, you can increase the range by adding a series resistor or increase the voltage. You just should know that. And then analog meter and a digital multimeter, that's on page 113 and 114. Please go through advantages of the digital multimeter. That's something they always ask.
I'm going to ask you how the digital multimeter work, explain electronically, then focus on the advantages of a digital multimeter, for the advantages that a digital multimeter have over a digital over an analog multimeter. Okay, that's it.